Alright. Let's
Dissecting
Emily, this video
And
is
our
for you.
expert medical opinion.
Not expert medical opinion. I
And the
think
next
we
step is
just,
take out the spleen.
we just take everything out.
Actually, just do the spinal cord while you're at it, you know?
Let's do what we did to Daphne.
Like a cat.
Poor cat.
Let's pick up here. So if I want to find the volume, so remember, when we did volume, it was like the area, right? We ended with saying you took the area of a cross section, which everything we looked at was circular. What's the area of a circle? Pi squared, and we would integrate from starting to stopping. Okay, so when we integrated that area, we got our volume. So if I want the volume of the solid obtained by rotating the region bounded by y equals x cubed, what's x cubed look like?
Sideways.
No, normal chair.
Normal chair.
Or yeah, whoops.
Okay, so that's my x
Y
cubed. Y equals 8, what's that?
The line
That's a
eight.
line. Straight
What?
sideways.
Horizontal line. Y equals 8. And x equals 0, what's that?
Diagonal, or not diagonal.
Vertical.
Straight down.
Vertical. So what I did is I really took this section of it. Okay, I'm bounding it by x equals 0. So I wasn't looking at the negatives. Y equals 8. I'm taking this part. And I am rotating that around the y-axis. So if I rotate that around the y,
Circle.
Blood cone.
it's going to look
Like half a lemon.
Half a lemon, yeah. 2 lines.
okay. So you see that's different than if I rotated it around the x-axis, right? So
Is that
the
what it
axis
means,
is
like
important. Yes, we rotate around the y. So when we do it in terms of x, that means we have to have a starting and stopping point for the x's. But I don't necessarily here. We might be able to solve for it, but my equation, y equals x cubed, if we have to pick a variable and go with it, okay? Typically, if you're rotating around the y-axis, don't we have a pretty clear lowest and highest point in terms of y?
Yeah.
Okay, so if we go with
Oh,
those,
8.
my low point is when y is 0, my high point is when y is 8. If those are y's, this has to be dy. That means my equation, pi times the radius squared, has to be in terms of y. All of your variables have to match. So if y is x cubed, how would you solve for that? That means x is
Cube root of y.
cube root of y. Because I want y to be my
Oh,
variable.
okay. I thought we wanted y to be our outside.
So, if you take a cross section, can we all agree this would be a circular cross section?
Oh yeah, we
And the radius, we are able to measure it right here, and it's just my curve, which is the cube root of y. Okay, so same thing we are doing, except these are all y values this time. So the pi we talked about, if you want, you can just pull it out in front of your integral. The cube root of y squared, you could write that as y to the 2/3 if you want. So when you do the antiderivative, add 1 to your power. So 5/3, so that means you need the reciprocal in front, 3/5. 0. I like to pull out any coefficients that I can. So that'd be a 3pi/5. If I put in 8, what that means is the cube root of 8 to the 5th. Cube root of 0 to the 5th. Cube root of 8 is 2 to the 5th is 32 minus 0. So 96 pi over 5. So the variable can be x or y. But this one, it wouldn't have been as easy to do it in terms of x. So that's why we set it up with our y's,
Is it
because we were
what?
rotating around the y.
The wasp.
He comes back every day. He really wants to live in here.
He wants to learn calculus.
He does come during this hour every day.
He just really is a distraction.
You just wants a death of.
Oh, Miss Jacob's gonna get murdered by the wasp. You cute.
Oh, I'm just trying to. Oh my goodness. He's not very smart.
I thought you were gonna turn around and he's just sitting on the paper like you brought him.
He's not very smart.
We
Boom!
need
Boom!
No, get down, Mr. Get down. He's
How
coming.
dare you not be smart? You're not good enough for Miss Drickle.
Oh.
Punchable by death.
Me and Michelle were getting something out of the closet, the athletic office, and there was a giant roach, like a roach the size of bigger than a $50, just dead on its back. And she just put it on Peterson's desk. And he walked in and he didn't even see it. He just started like putting his food next to it. And I was like,
There for a while last year during tax season, there was cockroaches.
they're everywhere. He's like, you can't be phased by cockroaches when you're a PE
They were
teacher.
bad.
There was a hissing cockroach in the girls' locker room one day.
Yeah. I stopped putting my bag on the ground. I would hang it up because I was scared I was going to get cockroaches in my bag.
If you come into school like after, they're huge. If you come into school like I come back after a basketball game because I put stuff away, and I'll go in the bathroom and because the lights are sensitive or whatever, you'll go in there like 4 cockroaches will just scatter and you're like, well, I guess I'll just wait to go to the bathroom until I get home. Because
Before had a cockroach in her room. It didn't even like walk like flat to the ground. Like it was like up on its legs. like it was walking.
Oh. He got into the chemical closet first.
that's not what I thought you were gonna say. I don't know what I thought you were gonna say.
So I caught it and I showed Miss Fuller. I was like, Miss Fuller with this walking cockroach. So she told me to put it out the window. So
No, this cockroach, this hissing cockroach, I always get out of the locker room before everyone else because I just change and get out. And this, I hear I'm like for like 3 minutes, I'm just standing in the weight room by myself and then I just hear like screaming. And so I go to investigate, I go back in there and they're like, there's a cockroach. And you just hear like, everybody is like screaming and running.
That's disgusting.
And then they caught it and they put it outside and I was like, okay.
No,
No, they put
I
it
would have
outside.
stomped it into the ground if
Yes,
I was that
absolutely.
scared.
They caught it. I was like, good on you, I guess.
Yeah, I would not catch the
Like whenever
cockroach.
there's a spider.
Alright, I'm glad we recorded this whole conversation, but let's take a look at a problem. So, if I want the volume of the solid formed when the region enclosed by the curves y equals x, and y equals x squared is rotated around the x-axis. So typically, I don't want to guarantee it's always, but typically if you're rotating around the x-axis, x will be your variable. When you're rotating around your y-axis, y will be your variable. The curve y equals x, what is that? Just a line. Okay. What about y equals x squared?
Oh no, just real parabola. I don't know. There were no other numbers, so I thought it didn't exist.
Okay. So what I'm doing is taking the region enclosed by the two of those. So you could really come in and erase this other stuff. This is the only part I'm looking at, the part that's enclosed by them. Now, could we find those values?
Yeah.
Yeah, we could just set x equal to x squared. So 0 and 1 are the points. And those are x values, so we need to integrate from 0 to 1, that is dx. We agree with that part?
Mm-hmm.
I am rotating this around the x-axis. So here's where my drawing becomes shameful. I'm not very good at this. So I am rotating this around the x. When I do that, I'm rotating this little solid part. What are we forming?
A cone?
A cone. So it's hollow in the middle. Okay? No, they both are. So you had this little banana-shaped region, and you rotated that. So it's hollow in the middle.
So we have to
Is it
find.
like sloped inward
Yes.
too?
So we
Yes.
find the cone and then we subtract the not cone.
Oh, okay.
Not cone.
So,
You find the cone and then find the cone inside the cone.
The not cone.
Did not cone.
The not cone.
so we're used to doing pi times the radius squared, right? But my radius is a little more complicated here because we have the outside and the inside, right? So what we're going to have to do is pi, and we're going to have to subtract those. So when I look at this, if I'm measuring my radius of a cross section, can we agree it would still be, it's kind of like circular shape, but it's like a donut, right? You look at a cross section, it's going to be hollow in the middle. So when you're measuring your radius, it's distance to the outside curve. The outside curve is my line, my x, but it's always the radius squared, minus the inside one is your x squared. So because it was hollow, we need to do pi r squared, but for the r, we have to do the outside squared minus the inside squared. Outside minus the inside. It's like subtracting those two areas.
Is it not squared after?
No, I put the square on each of these.
Oh.
Why
Okay.
do we square each of those?
Because it's a circle, we want the area of that circle. So it's like the outside circle minus the
So
inside
we
circle.
don't actually square the entire thing.
Right.
Okay.
If you wanted, you could do the pi with each of them. So it's like the outside circle minus pi times the inside circle. So it's like the area of the outside minus the area of the
Wait,
inside.
how do you pick the outside and the inside?
Think about if you drew your radius from the x-axis, the furthest one out.
Oh.
So we get x squared minus x to the fourth dx. So, antiderivative of x squared, 1/3 x cubed. Antiderivative of x to the fourth, 1/5 x to the fifth. So 1/3 minus 1/5. Minus greater than 0, you just get 0.
Pi over 15?
2 pi over 15.
Oh, yes, yes, yes. I tried to, I knew I needed 15, so I just got the 15 but did not think the numerator.
So this is what happens anytime we have two functions rotating around the axis at the same time. The next slide I tried to draw a picture. It's not all that impressive, but your cross section, it looks more like a washer or a donut at this point. So you have to do the outside area minus the inside area. So that's called the washer method. The ones we looked at Thursday in our first example today, those were solid in the middle. So that's called the disc method. They were just a solid disc. When there's two, you have the hollowed out part. So that's your washer method. That's what we just looked at.
You keep drawing on your art, but it's so much better than mine.
Oh, thank you. So I'd like to do maybe 2 more problems and then let you guys try some. These take a little more effort, thought, so I want to make sure I'm giving you guys plenty of time for this to work. So if I want the volume of the solid obtained by rotating the region in example 6a about the line y equals 2. Okay. So 6a is what we just got done doing, right? That was my line, y equals x, and my parabola. Okay, that was when my x was 1, x was 0. So that's what we just did. Last time we rotated around the axis, but if I rotate this around the line y equals 2,
You could have used the picture.
I tried, but that wasn't what my selector caught. So y equals 2 is right here. If you are rotating that,
Really large.
Really
Oh,
fat.
I didn't give myself a little space either.
Has a really big hole.
so I usually, when I'm trying to draw these, I think of it as a reflection first. If you just reflected it across that line, you would have your line here. So, like I said, don't judge me too much.
It's like a little bug.
It's just like the wings of bug. Oh, I did not draw the rest of my picture.
So my solid, it's like all this. It's kind of like I don't know. I always think of a Christmas tree stand, but that's not what you guys think of. We always had a real Christmas tree.
Yeah, I guess.
Hollow.
It's like a lampshade.
It's one of those
Yeah,
screw-
lampshade.
With the screw-in things.
All right. So when I am rotating this, we're still rotating around a horizontal line. So I think we can still do it in terms of x. We're still going to go from 0 to 1. And variable is x. But we have to be a little more careful. If we take a cross section, so if I slice it right here, okay, can we all agree we're looking at a circle that's hollowed out in the middle? Okay, when I measure my radius, it's measuring from 2. So it's the outside. Which one's on the outside now? The parabola or the line? The parabola.
I don't know what the outside is.
So the radius there is 2 minus x squared. So you're starting at 2, subtracting off this instead of the square. And we have to do the radius squared, right? Minus, then we have to subtract off the middle part. So the middle one, 2 minus x squared. Alright, so we don't have to rotate around an axis. It's much nicer, but we could rotate around any horizontal or vertical line.
Why is it 2 minus?
Because you're already starting at 2, and so your radius is that 2 to whatever point. Alright, so if we start foiling this up, we get 4 minus 4x squared plus x to the 4th. Minus 4. So if I FOIL both of those, should be my negative. Combine my terms, the 4's cancel. We have x to the 4th minus 5x squared plus 4x. And go negative. Any questions there? Can we do one final problem and then stop for the day?
Yes.
Now everything changes.
So find the volume of the solid obtained by rotating that same region down the line x equals negative 1. So, y equals x. Y equals x squared. That was our original. If x equals negative 1, it's a vertical line at negative
Oh, what's I put?
x equals would be vertical. similar. It's like a bowl, hollow in the middle, solid on the outside. But this time, is it easy to pick out an x, the lowest and highest x values? We can for the whole thing, but the x values here are different than the x values down here, right? But if you took vertical cross sections, aren't the highest and lowest y's the same every time? So this will be what you want to do in terms of y. Typically, if you're rotating around vertical lines, it's probably easier to do it in terms of y. Horizontal lines, probably in terms of x. All right, so my y values. The 0 and 1 were from x's, but remember the lines, the curves we were looking at? If you put in 0, the y is still 0. If x is 1, then y is 1, so that doesn't change much. Okay, it's still hollow, so we have to do the outside 1 squared minus the inside 1 squared. So, if I take a cross section, it's circular, we're just getting that bowl there. The radius,
The first one would be x, and the second, the further one out is the square.
so we're starting at -1, right? Did he come back?
I think that was Amber's split.
Okay. But if we want to keep it in terms of y, that kind of changes things, doesn't it? Maybe I should have saved this one for tomorrow. It's gonna take a little bit
X
longer than I
equals the
anticipated.
square root of y.
Can I pick up with this one more? Because I really wanted to let you guys try a couple problems, and this one is about to take a little bit longer than I
Absolutely.
anticipated. Is that okay?
Good luck, Carson.
Do you want me to finish it for you, Carson?
No, it's okay.
Okay. I will just pick up with this